this talk will be, it'll be honestly like a little bit short. I am like super congested from a very dusty hotel, so apologies if I go a little slow. Okay, yeah, so PBS expansion pack, Land of L2s. So probably for the last like year and a half, PBS has been like a very hot topic, and just recently, PBS in the context of L2s has started to come up. There's been a couple people like Aztec, like Lanaa, and some other like also optimistic rollups, Optimism. I think there's been some prototypes for a PBS like interface over there. So yeah, I'm basically just going to like do a bit of motivation, talk a little bit about why L2 PBS is different than L1 PBS. And some of the challenges, and then I'll mostly stop there. You can catch me at a talk later in the week on like some more clarifications on like the design space. Yeah, big disclaimer. I know like nothing about rollups. I'm glad John Char's not here. I've known about them for a while, obviously, but I've only really started looking into them like a couple weeks ago in the context of PBS. So, yeah, I'll say some things wrong. I still don't know what a sovereign rollup is. If anyone knows, let me know. Okay, cool. Yeah, so the prompt Grace7x gave me was like rollup MEV, and I think like just the most obvious classification to me is like exogenous and endogenous. So that's MEV, that's like cross rollup or cross domain. I think that's also similar to L1 to L2 MEV, and then just MEV on the rollup as well. Like looks pretty much the same, except it's a little bit faster. Yeah, so exogenous MEV, it's a thing. There's a paper on cross-domain MEV, like check it out. The use of the word domain also expands it into like Binance as well and other centralized exchanges. Yeah, rollups don't really change any fundamentals there, nothing big. One thing that is interesting, like it increases with the number of domains. That's really like something that's really interesting, like in the cow swap model specifically. Although cow swap is like minimizing MEV, but the more domains that like, something like a cow swap format can handle, it like actually increases the number of incidents once. So that's pretty cool, I think. Endogenous MEV, so on the rollup, one interesting thing is there's a lot of talk of like loss versus rebalance, LVR. There was a paper by like Tim Roughgarden and Jason, and here's like a summary of like one of the key terms from AIN, Alex Mislavin. Yeah, the rate of return on arbitrage increases roughly with like the square root of the block time. So just the longer the block time, the more MEV is sort of how you can think about it. So even, I think some people even say like almost 50% of arbitrage MEV like gets taken away just by lowering the block times to like 2 seconds. It's kind of like a hand wavy number, but you could roughly think of it like that. Yeah, so rollup MEV exists, what do? So this was like almost 4 years ago. Carl from Optimism had talked about a MEV auction. So it has been like very much referenced in the land of L2s. But this even like in some ways is like this larger ETH research post is like a precursor of just PBS on L1 too, which is pretty interesting. But it hasn't, like we don't really have MEV auctions yet. So that was more the Optimism approach, but then also you've obviously seen Arbitrum, like I think almost 2 years ago, there was like all of the drama, I think, was like between the Optimism and Arbitrum approach. Yeah, so Arbitrum had tried to handle this with like first come, first serve. And then there was this recent paper that came out which was a collab between Off-Chain Labs and then Christoph Schlegel, who's at Flashbots now. And the idea was basically to like, instead of just straight up first come, first serve, you turn it into more of a batch auction where, and this is their time boost design, where you can sort of like buy yourself back in time in a way. And then here's some also interesting research from Sexy Sun at Flashbots on like the number of conflicts as the block size increases. And so this was like his recommendation for basically the size of the batch auction interval. I don't know actually what Arbitrum has settled on, so I don't have much to offer there except for just like this was where the design space largely was for a while. Okay, so what is PBS if you're unfamiliar? This meme does it all. Yeah, there's a good quote from Barnaby in Notes on Proposer-Builder Separation. Basically, first and foremost, it's a design philosophy recognizing that protocol actors may invoke services from third parties over the course of their consensus duties. So yeah, we have this on L1 today with MebBoost. And so like this is the rough design. Yeah, like searchers, users, builders, the mempool, or searchers and users, and then the mempool all kind of feed into a builder. They send blocks to this like party called a relay. Basically, then when a validator is up, when its turn to propose a block comes up, it, asks this like little sidecar, runs MebBoost to fetch like the best fetch blocks from all the relays it's connected to. It will then pick the highest paying one and then do some like magic and commit to that block. And it's like sometimes safe, although there is no tax. So why would a rollup want PBS? It's like an interesting question because a lot of the sequencers themselves are like a single entity. So you don't have this like rotating property that you do in the validator set on like Ethereum L1. It's one possible way to a path to decentralizing the sequencer. I don't think it's like the full answer, but it's like part of that, I think. And then lastly, a market for block construction. We have seen a ton of innovation in the block space markets. I think there's even things like, builders are like fronting gas for searchers and all these other things. I see people in the audience who have implemented that. Yeah, so I think it's in the best interest of most chains to incentivize some type of market for block construction because it's very hard to replicate that innovation on your own, like just on a single piece of software that you write. And even additionally, you can imagine there being even like different types of block constructions that you would want on L2. That might be another reason for innovation there. Okay. So this is where I really get into sticky water by describing rollups. So like this is roughly a rollup, right? You have a set of like, you compress a bunch of transactions and then you create a post-state route and you push it to this like rollup contract. And I'm not saying anything yet about like who's actually doing this, but like that's it. You just compress some data, shove it on the ETH L1 chain. There's supposed to be this says ETH L1 chain. Okay, this is where John Sharp comes in. I think that is like different for sovereign rollups, but I think everything is a sovereign rollup now. But I think there's a different model in Celestia. I think slightly. I'll ignore that. So yeah, so this is what it looks like with just one sequencer, just users to the L2 sequencer, and so I'm kind of just going to describe a bunch of the different actors so that we can just see like where some type of PBS like interface might come in. And additionally, once we get to like ZK, you'll see it might actually be like proposer-prover separation as well. Yeah, so this is what it looks like. You could imagine, well actually let's just get forward. So yeah, the next like type of constraint you could think about is instead of just one sequencer, there's actually like a network of sequencers. There's a bunch of people working on these types of designs and in various like shapes and forms. You can see how this ends up looking like a little bit more like ETH L1 if there is like some type of shared sequencer architecture. It's just a good meme from Gort. Yeah, just stop trying to share the sequencer. I don't endorse that. Okay, cool. So yeah, and then so like one hidden complexity here is like I'm not even showing how there's actually an ETH L1 block builder here. While the sequencer, may have the sole rights to update the block, they actually still do need to compete with the L1 block building market since 90% of blocks go through that pipeline. So that's like even a hidden complexity. There's already an ingrained PBS right here. Yeah, and so yeah, we do this entire flow like right here in between the sequencer and the validator. And then there's also this other thing called like a based rollup or L1 sequenced, and so instead of like the sequencer being the only party that's allowed to like write, it's sort of a bunch of people try and write to the chain, and whatever just ends up on chain becomes like the canonical rollup block. So yeah, in that world, it looks more like you have a bunch of L2 block builders that are trying to post to L1 through an L1 block builder. So block builders on block builders. And then yeah, but wait, that's only optimistic rollups. Next we introduce like a prover. I think there was already talks on this, so I won't go too deep. Yeah, so roughly what happens is the L2 sequencer has a block, but they also send it to a prover to create a proof, and then not only do they submit this updated state root plus the compressed data, but they also include a proof in it. So that, in itself could be a complication, but then some projects also want a prover network, which again complicates things. And then like if we take this to its limit, you have potentially a shared sequencer network, potentially a prover network, and this is like 3 points for PBS. I'm not saying you actually need 3 PBSs here, but like that's where this gets really fun. Yeah, like it's like a lot of complexity, and we barely fully understand like L1 PBS. I think we're not even like totally sure it's like really the right path in some instances. So yeah. Okay, so I'll go into a couple designs from here. This is pretty much the end, but like, so Lanaa I think is, and I'm going to try and focus on designs that I haven't really heard of recently. Like I've heard of a lot of other designs, but I think these are some of the newer ones that are interesting. Yeah, so Lanaa, they have a rollup coordinator is what this role is, and it's essentially, it coordinates the sequencer and the prover. But in production right now, it is both. So yeah, that's like the centralized version. So in this case, we only really need to do PBS between this coordinator potentially and ETH L1. But you could imagine expanding it into. I think what would be most interesting probably is creating a prover network first, as opposed to trying to like create PBS in between the sequencer and the L1. Yeah, so then there's also Tycho. Tycho is also, I find the Tycho design interesting because they are trying to go for like a based rollup, and they additionally, they propose blocks on ETH L1 and then they start proving them off of what has been posted, instead of some designs where you don't even post until you start communicating with the prover. So yeah, like that leads to some interesting things. One, if you notice, they have these 3 different states: so proposed, proved, and verified. So the difference between proved and verified is that verified means you are proved and your parent has been verified. So there's like these like sort of nasty attacks in the current design where if the data somehow becomes unavailable for like proving a like parent block of something that's already been proved, then you might actually never be able to like become verified, and it's sort of like a liveliness issue. They have a lot of redundancy right now is like the hand wavy answer, but like I think that'll be something very interesting to solve in the long term. And then last, I wouldn't even pay attention to this diagram. I'll just like talk. Yeah, so Aztec also had an RFC or Q, no RFC for like L2 PBS designs, and the 2 main ones were for Net and B52. I won't really go into them, but what's interesting is that they chose this design they call Fernet, and they also accidentally introduced, well, as they started working on this design, they introduced like something called a withholding attack, where now instead of just like the data getting lost, it's actually the prover can purposefully withhold the proof to like force a reorg. If the reorg is more profitable than the value they would get by submitting the proof to the network, then they just purposefully like never give it in, take the slash, and then try and work on another block to counter this. So yeah, I think the takeaway really is just like there are lots of complications here. I don't really have any answers at the moment. Yeah, I think another interesting thing is like privacy. So like, you know, ZK, you know, you're providing a proof on a claim, and so depending on the claim you make, you're actually sort of like revealing some information. So I think that's like another design constraint here. Yeah, and then last, also, I think even further long term, proof singularity is like an interesting layer to this because, you know, this is this idea that just like Ethereum, every block is just like one proof that is like an aggregate of aggregates of proofs. You're eventually going to need one sort of like virtual machine to take an array of proofs and then construct a proof for it. And I think it's very interesting to think of like how that's sort of another layer of someone needs to aggregate these proofs, and that's like a sort of another market that needs to become available, and they potentially have their own incentives and differences in how they would proceed. And that's it. What's up?
How do you enforce, let's say I don't want my layer 2 users to be front run under PBS construction without saying the word swap?
How do you enforce them to not be front run?
Yeah, let's say I have PBS, and how do I ensure that it's not my users not being front run?
I don't know. I think it's really hard to prove front running. I think the fast lane work shows that like on shorter block times, it actually becomes much harder to produce front running. I mean, with PBS, I guess you're saying that because you have some like type of bundle activity. I don't know. I think it's not just PBS, but it's the way that the builder interacts with the searcher's preference that allows for the front running.
Can you say more on that? The last point, I don't think I understood the last point.
Well, if you have like a first come first serve builder, then you know it's harder to do block. It's harder to do front running there. But you can still imagine like multiple different builders with like slight variations on first come first serve, such as like time boost or something else like that, and that's where the front running has to occur at the block builder level.
Okay, so you're saying the users only send order flow to builders who are not front running, so it become an order flow thing to prevent front running.
I'm saying yeah, that's where front running lives.
I think actually like FlashBus makes the front ending much easier, and it doesn't do anything to prevent it. So it's a fact. So unless you have privacy and SGA for like threshold encryption, right now the block users are sandwiching front ending even more like it's centralized.
Yeah, bundles do allow you to express front running.
I mean like right now it's even worse, right? But like FlashBus has built it solved the problem of like priority gas actions on-chain, but it has made the front running thing like even like more centralized. There are two block users with the majority of those pull up like sandwiching transactions inside the block, and they don't like I don't know. Technically, you can send your transaction to a block user who is not front running, but that block user will never win the competition, right? Because they cannot be as much as the other ones.
It's not actually the block builders who do the front running, it's the searchers to send the block builders.
Yeah, but they can just.
Yeah, but I mean, FlashBus protects when, like, it's not, you're not facing like long block latency if you send to like a searcher like RPC that doesn't share. Like FlashBus protect just like doesn't and let you get front run. It's like fine from like a latency perspective. So like yeah, of course, like the model of like a PBS, but like it's fundamentally just like where do you want the option to occur, right? Like if your transactions can be shared and visibly seen before they're settled, then you can be front run.
Even if you send it to the private RPC, they will extract as much as possible to compete with the other ones. Right?
Yeah, exactly.
So there's no front running.
Yeah, and like TFL, right, like prevents this, but like TFL does it through like a composer cartel, right, where it's all validators of TFL.
I mean, the point is that like there is no front running protection. There is like the kind of
if you have public order flow, you can't set front running.
I think it's more the trusted options though, because if you currently send transactions, say through a media blocker or flash bus protect, there hasn't been provable cases of front running actually occurring. The front running actually only occurs when you send it to the public company, but there's some trust assumptions.
That's like campus.
Yeah, I would also say, I mean, Mev Share is an example. You can't front run on Mev Share. We only, we reveal a selective amount of information about your transaction, and we only accept back runs. So that's one example of like a mechanism that you can implement. I think the bundle is just making a block programmable, and so, or making your preferences and how the block is constructed more programmable. So, yes, a bundle does not solve front running. And I think the original question was like, how do you solve front running on L2, right?
More like, if you do PBS, you can prevent front running, and that's the.
You can't.
You can't unless you trust the builders to not front run, and then you just like where do you place a trust assumption, right? You place a trust assumption right now on the centralized sequencer to not front run, and in PBS then you place on the builders to not front run, something like that.
Place it more on the RPC that shares it too.
Yeah. I'm assuming bundling a bunch of things together to the builder part. Yeah, but
Yeah.
exactly.
I mean, if you shared a Mev Share, you'll never get front run.
Yeah, because we're trusting the centralized entity.
Yes.
Yes. Yeah.
And eventually you will lose the competition. Even right now, FlashPass is 10% of the block building, and the other ones, like Beaver has like 50, and the other one has like 60% of the network, and you cannot compete with those because they can offer much higher bits to the validators, right?
I mean, I don't think it's so like one-dimensional. There's like a lot of different options going on for block space, like sex stacks,
you have like
arbitrage.
more degrees of freedom, right?
If you're open to what?
To sandwiching, right? To like even front running. So FlashPass only have back running, and those guys have front running, back running, and all of the other strategies. So eventually, like it's a matter of time that they will be like much higher competitive than.
I would be interested in research that says front running is the only difference in all blocks. I think most of the research says it's all sex.
There are some research like that was suggesting that all of the whole block of like beavers, they are like private transaction sandwiching. Like, it's the reason that they are most
Beavers essentially, like they mainly do sex stacks arbitrage.
Yeah, but it's like front running to like.
Well, people send front running, people send sandwiching to Beaver and Flashbots everyone.
But I don't know. Did you see the research? I don't know. But they mentioned that the reason that they're competitive, those two, are exactly because of sandwiching.
No.
There was some research on that.
No, sex stacks.
Yeah.
Like sandwiching is like on the margin more profitable, but it's not as dominant.
That's okay. So there's a
Yeah,
part of that, and
it's on the
the
margin,
competitive
but
edge is the
Yeah, it's just like it's unclear if the market like
Okay, so the
concentrates
reason that
too, where
you
that
end up
is like a
winning is that
differentiator
part.
that boxes out like any other like all this thing happening. Where sex stacks is like by far like the largest revenue stream of like the user per builder, and that's not.
I mean, is that correct? That the bulk of it is like sex stacks,
Yeah.
but the competitive edge, the thing that makes you to win that.
Yeah, it was unclear if like having a better competitive edge in your sex stacks arb is like a much
That's just
stronger
not true.
profit leading thing than like having like a marginal edge on like sandwiching. Unclear.
Yeah, it's like saying if you had some small profit on some opportunity no one knows about, you're suddenly going to dominate the block building market. Like it's just not how it works. You have a question?
If you apply swap, right, on the L2s or rollups, which part do you feel like, I mean, more like sort of beneficial?
What is
Swap.
If you applied Suave into
Yeah.
this diagram,
Yes.
that's a fun one. All of it. It's the L1 chain, it's the user.
So the first step.
We view the first step as basically probably just this user to the sequencer right now. So yeah, basically running auctions on SGX that are like temporary, like not like long-lived, so that you only trust the SGX for small periods of time, and you can do something like Mev Share, and then you give it to the sequencer over the block builder.
In that case, you don't need the sequencer. Your SJX can directly execute transactions. Yeah. So you can directly replace that part.
No.
We are not focused on that, no. Like, could a sequencer run on SGX, if that's what you're saying? Like, yes. Yeah, that could be an interesting design space to explore. Yeah. Cool.
would be needed for the sequences? Like, I see that they're using like tenement or hot stuff variants, so would the PBS apply still to L2s?
If they're using like
something like tenement, or like I see Expresso trying to use hot stuff, and Starknet is using tenement. So like with their shared sequencing, the PBS might not be a problem, right, in the L2 space.
We're like also doing shared sequencing, and we use Tendermint for it. Unclear what the like latency thing. We'd like probably refer to like Jinwan, like Sexy Sun's like thing on like block timing, right? And so there's a question of like, what is the amount, like depending on how you do like a PBS or like an ePBS design within like a chain, you could like structurally like a shared sequencer starts looking like an L1, and that you have like multiple parties in consensus and rotating lead set, and you can choose to do PBS for block production, and that will be the economically valid thing. And then it's just really block time is probably like the relevant entity there. Hotshot allows you to have optimistic block timing, wherein if you have like a better connected peer-to-peer network, you can progress blocks faster. Tendermint runs on like a timeout-based thing, where it essentially says like the round must progress after this many times. It's either an empty block or like a proposed block. The kind of open question is like the economic benefit of like being a proposer, and whether it is ever advantageous for them to produce a block faster than their maximum time, because more MEV happens over a longer time. So generally we naively assume that proposers will choose to take the maximum block time, and so the only actual kind of like mechanism design difference you have is you have like a shorter block time. We're looking at ballpark like 2 seconds, but like that's just because you can easily get that with Tendermint. You can compress it down, like doing optimization like say into like half a second, and I think Hotshot can get like lower because they have like a one less round in their consensus. But then you just get in a trade-off space over like efficiency of your peer-to-peer network. So it really, all of it is just going to be a like time, like just time of the block. And so you will have like less MEV, and probably the best like practical research there would be looking at like any of like Jito's public research on how they're doing MEV on Solana, and there's going to be a lot of distinctions there, but they're looking at like a 400 millisecond block time. So you would at least have some question of like how does this market look like in like much shorter block times. But structurally we think it'll be roughly the same, but you probably have more centralization to your builder searcher market, but probably a lower number of sequencers that they have to communicate with the network. And so you just have more tightly connected networks at lower latencies.
Yeah, so TLDR, PBS L2, you need to be a consensus and mechanism design expert and a latency optimizer.
Yeah, last question.
Oh, can you go to the without the prover market, the slide with a shared sequencer? Yeah. So other question is, let's say you have 3 L2s with different transaction ordering policy. One is like, oh, I don't care, do anything. One is like never front run, like oh encrypted, whatever. And last one is you can only do back running. So now you have 3 different block builders who are sort of building this individual L2 blocks. Do you need a meta shared sequencer block builder to build blocks among the L2s you shared sequencer of? Like, does that even make sense? Curious, anyone's thoughts?
I feel like I have
Typically, you will have different site of sequencers for each rollup. Yeah. So otherwise, because in that case, your execution engine will be different. Yeah, it's highly sort of coupled with the execution engine.
Yeah, no, I'm saying the builder, sure, they have different things, but at the end, the shared sequencer have like individual blocks, right? So how do you?
It depends on the properties you want of a shared sequencer. Like an naive construction of a shared sequencer is that you have like one block for all rollups, and they have to accept the ordering policies that like, whether like they have to, right? It's like social consensus, what is like a valid full node of a given rollup, and how they choose to derive their state out of executing like an ordered block. So they could either inherit that same thing, they could like deterministically reorg that. You could also say that like one transaction in a given shared sequencer block is the entirety of a block for like an L2, and therefore it's assumed you have some off-chain builder. The design space is pretty wholly generic, but the trade-off primarily is if you have a different ordering policy on like a given L2 that uses a shared sequencer, you're not actually going to get any like useful definition of like composability or like relative ordering of transactions. You essentially just are borrowing a consensus engine and saying like all of these are like wholly sharded, like ordered lists.
Wholly sharded, that's it.
Holy sharding. Meme it.
Partially.
Okay, cool.
Thank you.
That's it, thanks.